everybody, welcome to this video tutorial. Today we're going to look at how to process a doubly linked list of nodes. We will be using Java to help illustrate the concepts. Let's get started. As we know, with linked lists we do need an external pointer, and today the external pointer is going to allow us to process a doubly linked list of nodes. Each node in a doubly linked list has data and a reference or a pointer to the next node in the list, and a reference or a pointer to the previous node in the list. The first node's previous pointer points to null, and the last node's next pointer points to null, which is similar to a singly linked list. In today's tutorial, the data in each node is going to be a reference to a frog object. So we are going to be processing nodes which contain a reference to frogs, and each frog has a name. We do need to figure out how to construct a new node and then insert it into the linked list. So let's just quickly take a look at the nature of a new node. When we construct a new node, we need to give it some data, which will be a frog, and we're going to set the next pointer to be null and the previous pointer to be null. And when we insert our new node into the list, we're going to be updating some of these pointers to allow the insertion to happen. With these ideas in mind, let's get started in our IDE. Now, to construct frogs, we do have the frog class, and I'm going to keep it as simple as possible. We'll just have one attribute, and we're not going to be using data hiding with mutator and accessor methods. We could. It doesn't change things very much, but let's keep things simple. When we construct a frog, we give it its name, and we can construct a frog object. Let's take a look at the nature of a node. A node has data, a reference to the next node in the list, and a reference to the previous node in the list. And when we construct a node, we give it a frog, and we assign that frog to be the data in the object, the node object, and we assign the next and previous nodes to be null. So that really matches this idea here. Okay. Now then, what we want to do now is I'm going to jump into main for a moment and try and think about what we're trying to achieve here. What we want to do is construct a linked list object. And our reference variable, myList, is going to allow us to communicate with that object. And what I want to be doing is calling linked list methods such as displayList. Now, we're not going to be using Java's linked list class. No, not for this tutorial. We're going to be designing our own linked list class, which is going to help us process a doubly linked list of nodes. Okay, so this is going to be our design. So the displayList method should display the name of every frog in the list. We should also be able to do this. We should be able to construct a new node. Okay, so after we run this line of code, we should get this situation here. We've got a new node, and we want to use our reference variable to communicate with our linked list here. And I'm just going to imagine a method called addTail, which I will be designing in a moment. And we're going to add the new node. Sorry, let's call that new node. We're going to be adding our new node to the linked list. Okay, and then we can display the list again. and see if it worked as expected. Okay, so let's try and see if we can figure out how to achieve these things through the linked list class that we're going to design. Now, really, when we construct a linked list, we just want to set the head of the list. This is really the external pointer to be null. Okay, so the linked list object only really requires to track that external pointer. That's the only attribute of our linked list class. Now what we want to do is design the display list method, which is going to iterate through the list from the head and display the name of every frog in the list. Okay, so if this is very similar, guys, to our singly linked list study, if the head is null, it means the list is empty. Okay. Else, it means we do have some nodes in the list, so let's go and search through the list and visit each node. Okay, so to do that, don't mess around with head. We're just going to create a new node reference. I'm going to call it search and assign that to the beginning of the list. And then we're going to iterate through the list. While search doesn't equal null, we're going to visit every node. We're going to print out. Well, what are we going to print out? Let's just go back to our drawing here. So search is here. We're going to say search dot data. The data is a reference to a frog object dot name. Now we're not using data hiding, so we don't have to say dot get name. We're just saying dot name. Okay. So search dot data dot name. So let's do that. Search dot data dot name. And after we've done that, we're going to update search to visit the next node in the list in this while loop. Search equals search dot next. So that's really a review of what we looked at with singly linked lists. Now let's go back to main. I'm just going to comment out some of this stuff. In fact, let's keep this. I want to see if this works. It should work, but let's display the current list. The list is empty. So the list is empty. We've constructed a new node. Now we're going to see if we can add that node to the tail of the list. So we're going to design the add tail method of the linked list class. And to add a node to the tail, we need to get a node from somewhere. I'm going to call it a new node. Now, as usual, if the head is null, then things are pretty straightforward. Again, let's just clear out some of this for a moment. We'll keep our new node. If the head is null, all we're going to do is say head equals new node, whatever new node is pointing to. And we don't have to update these pointers because this will be the first node in the list. The next pointer is null and the previous pointer is also null. So the only thing we have to do is say head is the same as new node. Okay? So that's pretty straightforward. Else, it means we have some nodes in the list and we need to go and search for the last node. Okay? So again, I'm going to create a search pointer. And while search dot next doesn't equal null, we're going to just step through the list. Now this is exactly the same as the logic we used with singly linked lists, so we're really reviewing singly linked lists with this. when we get out of the while loop, when that's finished, it means we have arrived here. Search is now pointing to this node here. Okay. So what we want to say is search.next equals new node. Doesn't equal null anymore. We're going to update that. Search.next equals new node. And new node dot prev equals search. We're going to update the previous pointer of that new node. And that will insert this node at the end of a doubly linked list. Search.next equals new node, and new node.prev equals search. So let's do that. Search.next equals new node, and new node.prev equals search. Done! We've just inserted a new node at the tail of a doubly linked list. Now let's go back to our main. I'll tell you what I'm going to do as well, guys. I've just thought of something. I want to go back into my linked list. I want to go back into the display list. When I display the name of each frog, I'm going to put the name into one line, just to make the output easy to understand. Okay. And before we leave the display list function, I am going to hack in there a new line, so that the next time we call this, we'll start again on a new line. Sorry, that just came to mind. I don't know why that came to mind, but you'll see why I've done that in a moment. Okay. So again, we've just figured out how to add a new node to the tail of a linked list. Now let's go back to main. Let's call that method, and then let's display the list and see if it works. So first our list was empty, and now we've just inserted Jack into the list. Let's insert another. I'm going to copy those 3 lines there. I'm going to make another node object. Let's call it Jill. We're going to add Jill to the tail, and then we're going to display the list again. Yay! So this is our new list of nodes, and we can just keep doing that. Hopefully it'll just keep working as expected. So that is how to insert a new node at the end of a doubly linked list. Take some time to think about it, code it, mess around with it, and see if you can figure out how to do that.